In this video, we're going to look at batch size versus one-piece flow in an office environment. So we know that we want to reduce the batch size as much as we can. In this particular model, though, we're going to have transport times that are going to make that a little bit difficult. So what we're going to have is we're going to have customers come in every 1 to 2 seconds, uniformly distributed. They're going to drop off a document. The processor at station 1 will take 1 second to process it. So with no variation, we've been very good. We got from other videos, we know it was important to get that variation down to 0 if we could, and we did. So he'll take exactly 1 second to process it, and then he'll move it to station 2. He'll pick it up and carry it. Station 2 will do it, 1 second as well, and he'll carry it to 3. 3 will process it, carry it to 4, and then 4 it'll leave the system. So each time they pick it up and move it to the other station, it takes 2 seconds to transport it there and 2 seconds to do the return trip. So let's go ahead and take a look at the model. And here are my controls. And we're going to run it at most for 1 day. And I'm going to hit play. So the customer's coming in. He's got a big old document to be processed. He gives it to him. He processes it. He processed it in 1 second, and now he's moving on. And another customer came in. He dropped off his document. He's now giving it to station 2, who's taking it to 3. 3's processing, gives it to 4, and then it leaves the system. We keep track of a few different statistics. We're going to keep track of how many were processed, so we saw 1 left. We're going to do the average time to process a document. So this could be called different things, but for our purposes, we're going to say the time that the customer dropped it off, the clock starts, and when 4 finished it, the clock ends. So we're keeping the track of the average time it went from drop off to when it left. We're also keeping track of how many documents are in the system at any time, either being processed, being moved, or waiting in a queue. So here, if we count them all up, there's 7. So we're going to go ahead and run this some more. And we can see they're all doing their jobs. We're keeping track of some other statistics too. The time a document spent waiting on average. So every time 1 leaves, we'll take the average of all that have left so far and add that time. The time traveling, which is 6 seconds, that we could calculate because it took 2 seconds for each move and there were 3 moves. Value added time. So we're going to assume that each of the processing steps are value added, and each took 1 second. There's 4 of them, so that makes sense that we'd get 4 as the result. Now what we're noticing here is that our system is not keeping up with the incoming documents. And I could speed this up a little bit, but we'll notice that queue just gets bigger and bigger and bigger. So I'm going to go ahead and pause it or stop it. This solution is not feasible. We know it's not going to work because if we kept running it, it would just get bigger and bigger. And I did verify that offline. So let's go to input. Let's go to here and change some values. I'm going to right click here. I'm going to say input editor. And this is where we could change either our batch size or the transport time. So let's go ahead and do batch size of 2. So I change it to 2. Then I either have to hit enter or click on a different line. It registers. You see how it moved a little bit? That shows it registered, and I can close this. And what we're going to do is we're going to do some experiments. We're going to fill this table in, not every value, but we're going to look at it for when transport time was 2, at different batch sizes, how long did it take to process that document from when it came in to when it left. Okay, and from the first one, we know if batch size is 1 that's not feasible. So we could, instead of writing a time, we could just write not feasible. It's not going to work at all. So we're going to do it for 2 seconds transport time and see what batch size we need for this to work. Later on, we're going to try experiments. What if we can reduce that transport time? And that's where it gets interesting. So let's go back. We got it set to 2 now. Let's go ahead and run this. And I've got it set 16. Okay, this is also not feasible because that's going to just keep growing. I did verify that offline too. So let's go ahead and, instead of running every combination, let's go up to 7. See if 7 works. Now, if you're an instructor for the class, you could have the class find it, have them try them all. Okay, let's go ahead and run this. Let's slow it down a little bit so we can have some suspense as it grows. So he comes in. He's going to make 7 dot. When he hits 7, he's going to go process it. Or, I'm sorry, transport it. Okay, so let's speed it up a little bit. So it's doing better than 1 did, that's for sure. Let's speed it up some more. It looks like we're almost keeping up. Let's speed up some more. But it's not. So 7's not feasible. By the way, I did check scenarios batch size 3 to 6, and all those were not feasible. But it takes longer before we realize it, so that's a good sign. Let's try 8. Go ahead and try 8. And 8's also not keeping up. Okay. Let's try it some more. I restarted it. I wasn't quite sure if I had cleared it out between runs. I just wanted to double check everything. Eight might keep up. Let's run it real fast so we can get to the end of the day. Okay, so now we've run it for 24 hours. First few seconds of warm-up I think we can ignore. 64.68. This one, 58 in Q. It looks like it's not keeping up, but let's write that down. Let's on our sheet. Let's write 64.68, and we could come back and examine it more if we need to. Okay. Now let's try 9. Make sure to hit enter so it registers. Make sure to clear it out. I'm going to slow it down a little bit just so we can see it slowly. Alright. So here's 9, and it seems to be keeping up. Let's speed it up some. 9's looking feasible. Okay, so now we run at 24 hours. We got almost no Q, so this is good. 9's feasible. And write down 36.36. We've got other stats too. I'll write those down. Let's clear out 9. Let's try 10. So 36.36. Remember that one. We'll run it with 10 now. And we'll just go real fast. So at 10, 39.35, write that down. And that got a little higher. Let's try 11. I'm going to clear out our old stats. Restart it. Okay, 11 gives us 42.53. We can write that down. It's getting higher now. So there's a different pattern. Okay, and at 12, looks like it's 45.76. So if we look at the results, 1 through 7 were not feasible, and I did verify that 3 to 6 were not feasible. 8's probably not feasible, but we didn't run it long enough. And 9 was feasible, and that gave us the best result, and then it started to go up. So what happened was, early on, we're spending all of our time transporting, so we don't have enough time actually processing to keep up with the work. But once we're at the desk long enough to do that by cutting down the number of transports, then we did very well. And what happened, if we start adding to the batch size, then we're waiting for the batch to be built longer, and then we went suboptimal. So it looks like number 9 for this situation is the optimal number. Let's go see what happens now. Maybe we've rearranged our desk and we put things closer together. So transport time is now half. And let's start off with batch size 3. And transport time is now 1. It's 1/2 of what it was. And we could go ahead. Let's run this. This goes faster. The average process time looked good, but it's not going to be able to keep up. So, by the way, I did run the other scenarios. 1 and 2 also were not feasible. 3 is not feasible. Let's try 4. I'm going to restart that just to make sure I remember to clear out the stats. I think I did, but I want to be sure. So let's speed it up some more. So 4 is growing. I'm not sure if it can keep up or not. We'll have to study it more. Let it run some more. Okay, so we got 49 working process. It took 49 seconds. I'm not sure if this is feasible or not. We haven't really run it long enough. It might work that queue down still. But for now, let's go ahead and write 49.01 down. Let's try 5. So here's 5. So 5's keeping up. We're already 12 hours in. So this one looked very good. 5 only gave 20.16 seconds. 13.16 waiting time. Okay. So remember the 13.16, you can write down to 20.16. Let's try 6. So now we're not traveling so much that we're at our desk enough to actually process these things. So 6 went up a little bit, 23.28. And we have a little bit more waiting time. That's because we're taking longer to build our bigger batch. So now it's the effect of the batch is starting to hurt us. And it's 7. Looks like we're going to hit around 26.51. Yep. Let's try 8. So it's showing the same pattern as before. Once we hit enough, once the batch size is large enough and we're not spending too much time transporting, then the impact of waiting for the batch as we got bigger just started to hurt us. So 29.75. So now it's going higher. So let's go ahead and take a look at the views. Here, The first 3 were not feasible, and I did verify the one that we skipped, the 2 that we skipped. 4 probably won't be feasible. We didn't run it long enough to tell, but it doesn't make a difference though, because 5 is definitely more optimal. So 5 is where we want to be here. So 9, when we had 2-second travel time, as we reduced the travel, we were able to get the batch size smaller. So let's go ahead and, that this maybe was from rearranging the desk. Let's say we've now got the desk into, say, a work cell of some kind so that there's no travel. Or let's say maybe we've found a way to do this electronically so that there's no travel. Okay? So let's go ahead and change travel to 0. To transport, I mean. And batch size to 1. Reset this. Let's go ahead and run this. I'm going to slow it down a little bit. Let's slow it down some more just so you can see. So now they're not having to travel. They're sending it electronically, or maybe we have them close enough physically that they could just hand it to the guy next to them. Don't worry about the negative sign on the waiting. That's just a little bit of round-off error. So now what we're seeing is with the batch size 0 and travel 0, things get a little bit better. And the numbers aren't changing very much. I could just stop it now. Okay, so we see time to process is 4 seconds because there's no waiting at all, no travel at all. So this is definitely working extremely well compared to the other ones. So if we could get the travel time or the transport time down to 0, or we get our batch size down to 1, that gives us the best result. And it's not even close. By the way, I did run it with 2, and it went up. So we know as we started to batch now, there was no reason to batch with 0 travel, so it would only give you suboptimal answers. So basically, transport time of 2 seconds, we had a batch size of 9. If we got the transport down to 1, the time to process is 20 seconds. Most of that time was wait time. We only reduced the transport by 3, right? But the rest of the other 13 seconds was because we had less waiting. And when we got down to 0, then of course we have these results down here. So the time to process goes down, the time waiting goes down, of course time traveling goes down as we reduce travel time, and the value added stays the same. So I think you can see from this that it's incredibly important to get your transport time down, and if your guide model with setup, also get the setup time down. That will allow you to get your batch time down, and that does a few things for you. One, it saves directly on the transport, but more importantly, it saves, because you don't have to go back and forth so many times, it saves you a lot of time as far as the waiting, because you get the batch size down, and you're not waiting for that either. So I hope you enjoy this. To me, this is very powerful.